All right, welcome back, generals, to another Let's Fix Generals 0 Hour to make the best game ever. We are still in development of the unassemblize tool to facilitate ASM assembler matching. And last video we did implement the look ahead matching of our assembler instructions. And we need to test this now. Yeah. Okay, so let's start from the top. We did quite a bit of changes here. Yeah, this function is quite big here. I wonder if we can break this down, this part here. I mean, this not, but oh, I realize here we have this. Mismatch. Okay, let's debug this. I mean, it's probably possible to refactor this a bit, but yeah, in the end, it's not so big. There are certainly larger functions out there. Okay, so instructions 0, 56. Yeah, okay, so we have 56 instruction arrays. Yeah, this looks okay. Empty instruction array. Yeah. So we have count. By the way, here on split instruction text, we do a resize. Okay, so it's optimal allocation. Yeah, let's take a look. So it's actually the first time we debug this, so let's look at this carefully. Looks like it's 2 or 3 here. I wonder. I wonder if this is too big here. Maybe we can make it smaller. We do have an assert here. Yeah. Okay, so estimated count. So we have count 455 times 1.2 546. Yeah. And then reserves. Okay, that's fair. Maybe we add a comment here. Reserve a little bit more. Reserve a little bit more for labels for potential labels. It would be nice to do it exact, which probably is possible. Get instructions. How about we have here instructions. Instructions. I do wonder if we should perhaps change the ASM instruction vector to also include a variant. Yeah, it's kind of weird that we have label here, right? So I wonder. Yeah, but it would be nice if this vector would also contain variant of either a label or this, right? But then But then the problem is it's so basically you would have a struct ASM instruction label. Then we do std string label. And then we're using std variant. No, using ASM instruction variant. So that would be either ASM instruction or the label. Maybe we put label first. So this would be include variant. And then we would here have using ASM instruction vector would be a vector of ASM instruction. And yeah, so let's see. So we would remove this here. Would also remove this. Then we would create a null instruction. Which would be like so, ASM instruction. Yeah. Then we would comment out this one. Then append as text. We would have this. And what have this? Yeah. So instruction vector. Let me see. So it would have instructions, and then Instruction variants. ASM instruction variants. Instruction dot. Wait, how do we std variant? There should be something like get if obtain a pointer. Yeah. Get if. Let's see. Get if int. Yeah. So if instruction get if label so if we get it as a label, then that we do instruction label. Hold on. Label. Label dot label. Label. Yeah. Else if well I think else doesn't need a condition because you only have two, so we do else instruction and this will have to instruction. Let's call this variant instruction get if and here we do instruction is invalid, just pointers. Yeah. Okay. So if it's a type label, then we do this label formatting. Otherwise, we do this stuff. Let's do here add a print label. Okay. And we have some more pain points here. Instruction count. Okay, so this instructions. Okay, then this is no longer correct here. Here we would then need to okay, so here we can do size t label count equals 0. Okay. Here we need to be careful. Uh, Okay, let's do here plus label counts. Okay, so we will have some label counts here, and then we do reserve. Reserve this plus label count. And then we do we should move this to the top. And label count probably needs to start with 1 because the function starts at a label, at an address with a label, the function name. Okay. I notice that here with this code, it means that if the first instruction was unrecognized, we never would get a label. This needs to go to the very top. Well, not to the very, very top, but close here. And then similar instruction, if not this empty, then is label label dot label equals that, and then instructions dot emplace asm label emplace. Is that correct? Emplace back. Emplace back. So we have this instructions. So and then here we do instruction, this ASM instruction, if I can type instruction, ASM instruction dot address, this runtime address. Then we remove this thing here, and then is invalid text this instruction index equals instruction count. This is fair. And here at the bottom we need to, oh, hold on. Oof. We should also std move, right? Address. Okay, so here we need to remove the continue, but then put here an else. And then here at the bottom we put this and place ASM instruction. Okay. Yeah, we should probably put a breakpoint here to debug this once. It's quite a significant change. Starts at 1 for the starts at 1 for the function label, for the likely function label. Okay, so this is adapted now. All this. Well, not all this. Almost. Instruction. Now it is. Okay. So, but now we need to adjust all this here as well. So we have instructions, empty instructions. Yeah, empty instruction, create null instruction. Okay, get instruction. Instruction. Okay, so this is no longer correct here. Okay, how do I deal with this? It needs to be this empty instruction. Actually needs to be a variant. Yeah, okay, so I think what we need is an instruction label, and we do an ASM instruction null with nothing inside. Null. So okay. ASM instruction null. Well, then if we have 3 types, then we need to get back here and do else if that. ASM instruction. This. Get. Oh. I think it should be the other way around. We first check for instruction and then we check for label. Reason being, it's more likely that we have an instruction and not a label. And we should always take the branch. Well, yeah, we should always take the branch that is more likely first. Yeah. Print instruction. Okay. We still have an error down here. Right. Fixed. Okay. So what we do is here, our null instruction well, then we don't need this function anymore. See, it all becomes simpler. don't need this, I think. Maybe you're wondering why I'm commenting out instead of deleting it straight away. There is a method to this. I like to like comment out things that I've done previously until I'm done with everything, because maybe I go back and touch it again if I realize, oh, okay, maybe I do need it, and then it's just a matter of uncommenting the stuff that I maybe need again. And when everything is done and dusted and I'm sure I don't need it, then I can make a pass and just delete everything that was commented and is obsolete. Yeah. Okay, so what we do here is we create an variant, empty instruction variant, and this one will be here, variant ASM instruction null. This should work. No? What? Why not? Type name is not allowed. Huh. Okay, so I cannot assign this. Assigns a variant. Constructs a value in the variance. So we need to call emplace. Okay, maybe we do need the function after all. See, now I go back and put it again. So this would be a variant. Create null instruction variant. So it is a variant. Variant. Wait, what happens if we do ASM instruction null? Oh, that works. Right, so can we do here like that? No. Why not? Declaration is incompatible. What's the problem? I don't understand. Why is this okay, but the other is not okay? I don't understand. Why is this okay? I don't understand. Why can I do it here, but not here? Or can I? Huh. Maybe it accepts it now. Well, let's comment it out again. Good. Okay, let's see how this goes. So we have... Okay, so here we also need to have variant. Variant, instruction 0. And s empty. Hold on. Instruction... Instructions. Okay, so here we can simply do std max this, reserve std max. Yeah. Okay, so this will work now. Okay, let's remove this. Okay, split instruction text. Resize size. Okay, so here we need to allocate yeah, so here we need to say if this thing variant get if instruction if instructions I. What's the problem here? Oh, what's the problem again? Instruction vector. Okay, I don't know why it works now. It's wild. Okay, so if this is true, then instruction text. And otherwise, if it's not ASM instruction, then we don't modify the array I. It's just will be an empty array because it's a label and then it's not valid. And yeah, but since we don't want to have different indices, we don't Yeah. Yeah, I think this is good. And it's also more explicit when we have those null instructions in our variants. Yeah, I think that's better. Okay, I think that's good. Maybe. Okay, let's work our way. Okay, with just this function here. Okay, there's a little bit of stuff to do. Okay, so now there can no longer be a label in an instruction. This actually makes things easier. This makes things easier. Yeah. So before we had this unholy situation where a label was also part of the instruction. We don't have this anymore. This actually makes things easier. This is good. Okay, so we just need to say I wonder if this is still a good name. ASM line. I don't know. Not important. Okay. I'm still thinking like how we go on here. Okay, I think we need to say if no, let's copy this. ASM match types, ASM instruction string. wonder if we should change this as well to asm label. I think that's a little bit better. Asm instruction label. Okay, but now we have a problem. So this is fine, but here is a match. Is a match. ASM instruction. Instruction pair. No, I think it's fine. Yeah. Okay, so here we need to say ASM empty. Let's call this null instruction variant. But null instruction. We cannot use null instruction. Yeah. No, we cannot use that. I think what we need to do is empty instruction okay, this variance is a little bit more complicated than I thought. But I think we can do it. What is index type? I suggest using index. No need for 8-byte integers. Size t is 8-byte. Okay. How do we handle I think empty instruction makes sense. Empty instruction. Okay, so we need a null instruction variant. But then we also need a ASM instruction as let's call this dummy instruction. Dummy instruction. And we do instruction label, dummy instruction label. I don't think we need the empty string anymore. Okay. So we have a dummy instruction, but hold on. Okay, it looks like we do need. create ASM instruction. Create ASM instruction. So it looks like we do need this after all. Okay. Okay. Okay, let's try this. So null instruction variant, this is just a dummy as well, so that this is not invalid. And then we say if we do instruction label 0, get if instruction 0. Then we do the same for 1. And then we say if instruction label is not null pointer or this not null pointer, one of these, then we have a label. So then we take this guy, ASM label, and we say if ASM label not null pointer, then ASM label well, I mean, in theory we could also have null. That makes sense. I wonder if it makes sense that we say these things can be null, right? Maybe that would be okay, right? I mean, they don't have to link to a dummy. If we just say they can be null, which is fair, just check them. Is it null or not? But on the other hand, there's also something to say where you need to check condition anyway. Label. I don't know. I don't know. Maybe it should link to label, to dummy, maybe not. So, okay, so what we can do is if instruction label, then do instruction label. Otherwise, do as dummy instruction label. pointer, right? 1, 1, 1. So we can do this. Yeah. And then basically here we can early return here, continue. No, we can't. We can't. Well, we could if we just realized that this was wrong, this here, because if one side had a label, then we would take that label, but we would still increment both. So this was actually wrong, and it still is wrong, but we can fix that. So we need to say if if instruction label 0 is not null pointer, then then instruction else asm equals dummy. Yeah. And then here we also need to plus I0. If it is an instruction label, we count up here. And then we do if instruction label 1, then 1, 1, 1, I1. Yeah. Okay, so this way we only actually count up where the label is. Yeah. Okay, this should be correct. It's a little bit more complicated now. I wonder if we should make this std array here. Std array. Std array this to instruction and then we say instruction 0 but then we need this also. I think that will make things even more complicated. We shouldn't do that. Let's keep this way. I mean, yeah, we have here some code duplication, which could be in a loop if we had this as indexes, but it will be more complicated in other ways. Let's keep it like this for now. Good, so if it's not null pointer, then we do this, and then we count up here. Otherwise, we take the dummy label and then we push that back. Yeah. And then I think we can continue here. Yeah. Okay. Then, I mean, after this instruction label, let's call this variant. Variant 1. Okay. And then here we do instruction 0 and 1. And this is ASM instruction variant 0. Yeah. And here the expectation is actually that this is not null pointer. Right? Because we don't expect any null instructions in those arrays. Right? And those variants. So we can make this assumption here. And then we can instruction 0 is invalid. Instruction 1 is invalid. It's matching. Yeah. Okay, then it also needs to be pointer. Okay, we're making decent progress, but it's a lot more changes than I anticipated. But it's good, we found this one problem here with our labels. This should be correct now. It's easy to make mistakes here. I need to be very careful. Needs good testing, yeah. I am sure that we can iron out all the errors once we spot them. Okay, so this seems to be solid, but I'm not 100% sure. Good. So basically, when we reach this point, The expectation is that these definitely both have to be instructions, because otherwise it will hit here, right? If one of these things is a label, it will hit this. So that means if it hits here, it must be, these things must be set. It must be an instruction. It cannot be a label anymore at this point, right? Okay. Good. So yeah, this seems to be okay. Good. Then we need to look at our look ahead thingy. Look ahead limits. Okay, now this look ahead. Okay. Look ahead limits. Yeah, the problem is now the look ahead limit includes labels because these are on a separate element. Good. Okay, this needs some thinking. Look ahead. Okay. Oof. STD next. I just, speaking of speed, what is he asking here? Const auto symbols STD next binary symbols begin. Hä? This line in debug slows the loop by 100. Okay, so I'm missing, I'm missing context here. Like, what are these types? I think that needs a bit more context. Okay, let's get back to code. Okay, so I'm a bit so the look ahead limit, before it was okay, we just set it to 20, but now since we have labels, our look ahead limit needs to be kind of dynamic, right? So we need actually now 2 as well. look at limit 0, 1. Look at limits. Okay. Okay, before we do this, let's do this first here. Okay, so here we have variant. Let's call this variant. And this as well. Yeah. Okay, so actually, okay, and then this should also be this. This the same thing here as this. Yeah. Instruction 0. And this should be. We don't need the static cast anymore. Just remove this. Yeah. Yeah. So this is search, it never hit. Yeah. Actually, hold on. Well, if it's out of bounds, then it hits. Meh. Yeah, I think the assumption with the assert is incorrect. This is actually incorrect because so here we say if if instruction 0 is null pointer or instruction 1 is null pointer, then is matching if instruction So if one of these instructions is null, then it's definitely a mismatch, right? Because we reached the end basically on one side, right? One function is longer than the other, we have reached the end, and that means we can simply do a mismatch here. So here's a mismatch. I think we do it similar to how we did for the label. So if instruction 0 is not null pointer, then do this, else assign this thing here as a mismatch dot get if it would be nice to simplify this somehow. I don't know. Instructions. Instruction, dummy instruction. One. That's it. Good. 1 1 1 1 1 0 0 0 0 1 1 1. Yeah. Okay, and then we would also here increment this. But not increment the other. I1. And then we can also do continue here. Continue. Okay, but now this guarantees that so at this point we guarantee there can't be a label left anymore. Both instructions both instructions can be no label, or both variants can be no label. Both variants can be not null. Can not be null. Can not be. Both variants cannot be labels. Both variants cannot be labels. Both variants cannot be null. Is a mismatch. I don't like this. Let's check labels. Check for any labels. Check for any missing. Check for missing instructions on either side. Missing instruction on either side. Okay, I think this is better. Okay, here we also need to put results dot is matching equals false. Okay, so basically we have like pre-checks here. Is it a label? Is it missing instruction? And if these conditions are met, we do early continue, right? Because there's no point moving on here. Like if these conditions are met, it's game over pretty much. Yeah. The disadvantage of this is that now we have like this logic here and then even more logic behind, so it makes things quite complicated. But I don't know, this more elegant way. It kind of is nice that we get out of the way what these things are, right? So here at this point, when we are here, we know that we have valid instruction on both sides, right? Well, apart from this thing here, right? Yeah, it is quite complicated. Okay, let's keep going. Let's see where it leads us. It is quite complicated already. Yeah. Okay, but we have a lot of green here now. It's not much red left. Okay, so at this point though, Okay, so, but here, when we reach this down here, then we know this can't be invalid anymore. I think. So I guess that's the upside. We know it can't be invalid. So this is now can be removed, I think. So this is expected to be a valid index now. Because if it was invalid, it would be catched here already, right? Because then here, one of these would be empty, right? And then this would be null pointer because this is a null instruction in here. So we would be in here already. So we would early out. So it gives us confidence here. Maybe we can put an assert here. Assert. So we expect that this is smaller than instructions.size. And this we expect to be smaller than this. Yeah. Good. And we also expect that these are now leftover instructions. Yeah. Either because we pass through here or because we passed here through the look ahead. Yeah. I think this is correct now. And this can be either matching. Is matching here. If this is all true. Is matching. Yeah. Variant. Is matching. Mismatch detail. Instruction array. Oof. I hope I make no mistakes here. Okay, but now it gets interesting here. We see look ahead. Oh my gosh. Okay, this function is actually really complicated. I don't know if it just overcomplicated it, but I mean it is a semi-complicated algorithm with a comparison. So we can expect a little bit of complexity, right? So that is a given. But I guess as long as we get it robust and working and everything good, I'm happy with it. But I have to say, it is a little bit complicated. Yeah. It is a bit complicated. Okay, let's go ahead. So, while these smaller counts. Aha, oh, hold on. This actually means, hold on, if we have here, okay, so it is possible that here we actually go over the counts. So this assert is actually incorrect. It's incorrect. So we do actually have to do this stuff here. Shit. Okay, well. Yeah, you need to be smart here. So it is this. Okay. So this means these things can also be null. Okay, so this actually means Bah. It means that we, oh my gosh. Can we somehow move this down? This stuff. That's very nice. So this is I plus K. Yeah, so this can go over count as we iterate here, right? And then I plus K 0 can be larger. Oh, hold on. Here we also need to K0. K1. I mean, this is correct technically, but can we move it backwards? We can't because of this. Okay, so my suspicion is that we basically need to make a copy of this thing and do the same thing here, pretty much. Yeah, I wonder if we should allow null pointer here. We need to check anyway, right? Like, well, yeah. Okay, so what I don't like is that here we have this thing, and then here at the bottom we need it again. This to me indicates that we do it too complicated. While I... instruction 0, 1. 0, 1. Oh boy. Instruction. Well, perhaps it's possible that we can remove this. Let me see. So we can say if instruction null pointer or this null pointer, then it's definitely mismatched, right? It's mismatching. It's true. Then put this back here. It's mismatching. So is matching is false if that's the case, and then we have else if. So now we need to be careful though, because one of these guys is not an ASM instruction. Eventually. All right. Okay, so I mean, if one of these is null, we won't check the other. So here we are safe. Here we are safe. And then so is matching must be true, because then these are not null. Okay, so here we put assert. This assert. Okay, and the mismatch, we do these things here. Then can also put this stuff we put in here. And this one counts just one up. It's matching this, else this. Okay. Let's remove this. Okay, so this makes sense to me. Oh boy. Man, this is complicated. Good. Missing instruction on one side. It's missing instruction on one side. Is invalid instruction on one side. Okay. Okay. This might be correct now, and this down here as well, but this is still important. We need to figure this out. Okay, so this condition is fine, but now here we have a problem with the look ahead limit. Okay, 0 smaller. Okay, look ahead left side is matching with base right side. Okay, I think we can manage here. Okay. Okay, look ahead mismatch detail is mess. Is I think here we should also put an assert. Oh, okay. Now we have a problem. If not is matching. If not is matching. put if not is matching, then we do this. It's matching. Maybe we just put this every time we do ASM. Maybe that's better. It's a mismatch. So we put it here, here, and here. I think that makes it robust. Okay, so if not is matching, and I think we need some conditions here as well. If not is matching. So the thing is, if one of these guys, is a null pointer, there's no, it doesn't make sense to look ahead. Look ahead to check if there is a match further up ahead. Look ahead to check if there's a match further ahead. Look ahead instructions to check if there's a match further ahead. Okay, so I think we need to say if not is matching and instruction not null pointer and well, but this one is okay. Instruction. Let's create a new bool here. It's mismatching and bool is, let's do can look ahead. How about that? Can look ahead true. And then we said can look ahead false here. So when one of these instructions is null, can look ahead false. So here if not is mismatching, no, if not matching, can look ahead. Or we do it actually different. We say can look ahead here true. Can look ahead. Can look ahead. Can look ahead. What about invalid? Yeah, invalid also makes no sense to look ahead. Actually, it makes sense. Can look ahead. Okay, so can look ahead. So we say can look ahead. Can look ahead. Is matching. Hold on. It's matching false. E. So set it to false. False. Okay, can look ahead. Do look ahead. Do look ahead. True. So do look ahead. Is matching. Let's put here assert is mismatch. Let's be specific with true. Okay, so is matching, wait, it's false. Look at. Okay, so we don't look ahead if instructions, if one of them is null, because it means we have reached the end, so we don't look ahead. And then what happens? We reach this here. So one of these again will be a null instruction variant. One of these will be null. This is expected false then, and then we go in here and we do this. Yeah, okay, this is probably correct. Probably. Probably. Say for. Okay, so okay, now we need to implement this. Okay, so we have look ahead, and we can assume that both are instructions. Yeah. So here we can also say look at instruction. Look ahead. Oof. Okay. Okay, what do we do here? Okay, so we need to check. So if instruction label, instruction so how about we call this just label? Okay, easier to read. Label 0, label 1. So if label 0 instruction 0 instruction 0 this. Let's actually let's make a variant this. Okay, variant 0 instruction this, that, this. Good. Okay, variant 0. So if this is a label, then first we will increase the look ahead limit because there is a label. Increase that, but also increase K0 plus plus K0 and continue, right? If there's a label. Good. Then if it's not a label, then we look at instruction arrays. Instruction arrays. Yeah. I wonder if we need to put an assert here. Maybe not. No, assert. Std get if actually I wonder. Actually, I think we can, if I'm not mistaken, there is concept of std get. No? Let me see. Get if get. How's this used? Get. Get int. Get. I'm not sure what's the problem here. To me, it looks like this should work. For some reason, to cons. Oh, right. Reference. There we go. Yeah. Okay, so here we also, so here we expect that this is not null pointer. So it's okay, so if look ahead, so basically this assert should never hit. So it's matching, then right. Okay, here it gets interesting. So again, we will have label. If label. Variant 0. Instructions. Okay. Okay, so if it's a label, then we put this in here and continue. Well, ASM instruction label, label variant, ASM label, 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 and here dummy instruction label. And then else I mean, otherwise it can only be else it can only be instruction 0 get variant zero instruction this function, man. It's one of those functions which is just difficult. Okay, what am I doing? This one here. So ASM mismatch, and here we do instruction 0 or as dummy instruction and look ahead mismatch detail and place back is mismatching false. Yeah, is matching false. Good, that means we can delete these guys. Okay, so this should be the new version for up here, and we need to replicate it for down here as well. So else so we need this. Hold on, what is happening here? Oh, this variance. Okay. Okay, so variant 1, instructions 1, I0, K0, label 1, variant 1, K1, look ahead limit 1. Skip over label. Skip over label. I wonder if we should simplify this to so 1 K1. We remove this. This goes in here. We remove this, that. Okay. Move this here. Take that, that. Instructions. Oh, easy to make mistakes here. I think we should try to make this a function. Because it's just so much. How do we do that? I don't think we can because, well, we can, but oof. Yeah, it would be nice if this was a function here, this whole thing. But for that we need this is wrong. Variance. I do kind of like this here though. Okay, 0. Yeah, so how can we, it would be really nice to make this a function here because it's just so complicated already. And here we have to do it twice. Okay. It means we would have a function. Well, how about we take break now and continue this next session? Yeah. I mean, if we create a function, we need to pass results. We need to pass this index. We need to pass this thing and this index, this index. We need to pass this as reference. We need to pass a lot of things. Yeah. But it's probably possible. Yeah. We should try to make this a... but hold on. Break. Matching. Yeah, we would have to return true in that function. it's matching. Because, so here does continue. So that would be a return. Yeah, let's do this next video session carefully. Yeah. Okay. Yeah, it's quite this function is quite something, but I think we are on the right track. Yeah, well, famous last words. Okay, we can try to make it one big function, but we need to pass so many arguments. We need to pass this k, this, and this, and this. Yeah. And probably a bunch of other things. Yeah. Okay, good. Well, as long as we make progress, that's good. All right, then let me save all. It doesn't compile right now, but that's okay. Yeah, let's finish this next session. It's already quite a bit late, 2:30. Yeah, I need some sleep. Then I wish you a great day or night until next time. Goodbye.